Now let us see the IUPAC naming of some cyclic compounds. Alright, so we know that we have to use cyclo when we are referring to the ring prefix. Alright, so let us start this, and if we start numbering this particular, the first one that we have over here, we start the numbering from this side and move on like this. And for this particular ring, this is 5-membered carbon ring. So this is pentyl, and therefore when we number this compound, we start from the right hand side. So 1, 2, and 3. And therefore the name of this compound now becomes, so this is 3-cyclo, and after cyclo, we'll write pentyl because of this 5-membered carbon ring. At 2, we have hydroxy because of the OH, and then we have propanoic acid. Alright, in the next one that we have over here, we start the numbering again from the right hand side. So 1, 2, 3, and 4. And now the name of this will be, so at 3 we have amino, 3 amino. Now at 4 there is an attachment of the cyclo ring, that is cyclo. And again we have pentyl. And then we call this butane because of the four carbon butane, and at 2 we have the OH, so 2 all right. Moving on over here to the third one, here we have 1, 2, 3, 4, all right. So now if let us put a double bond over in this cyclic ring, so when this happens, what happens is we have to number this ring also, as we will be mentioning this particular attachment of this double bond in this IUPAC name. So how do we do that? At 4 we have this 2 dash, and at 2 dash we have the connection of double bond, so we call this as cyclo butynyl. Notice this En comes from the double bond enyl. At 3 we have hydroxy, and then at 2 we have the double bond O, so butane on. Alright, so this is how we name this particular ring. Now coming on to this one, the next one that we have over here, we start the numbering now from this side because the OH, the functional group, appears here. So 1, 2, 3, 4, and now this whole ring, so 4, 5, and 6. Alright, so the name of this becomes, so at 6 we have bromo, 6 bromo, 5 chloro. Alright, then we have the cyclo, hex, 3 ene. Alright, all. So 6 we have bromo group, at 5 we have the chloro group, and then we have the cyclic ring, so cyclo, and at 3 we have a double bond, so 3 ene, and then we have all because of the OH. Moving on to the next one over here. So in this one, we start the numbering where the functional group appears, that is NH2. So 1, move to the top, 2, 3, 4, 5, and 6. And the name of this compound now becomes, so we call this as 6-ethyl, 3-methyl, cyclohexenamide. Alright. Moving on to the next one now. So here we start the numbering from OH. So 1, 2, 3, 4, 5, and 6. So the name of this compound now becomes, so here we have 4 amino, 4 amino, then we have 3 chloro, then we have cyclohexanol. Alright. In the next one that we have over here, we start the numbering where OH appears. So 1, 2, 3, 4, and 5. And the name of this compound now is 2-bromo. Then we have 5-methyl. Then we have cyclo. And then it is pentanol. All right. In the next one that we have over here, we start the numbering again from where OH appears. So 1, 2, 3, 4, and 5. And now the name of this particular one becomes, so this is 3,5 dimethyl, and then we have cyclopentanol. All right. So at one we have the double bond also, and at one we have the OH group also. So pentanol, all at once. All right. In the next one that we have over here, so in these ones, let us start the numbering now. Quite easy to understand for us now. So at first we see the OH has the highest priority, and here we have OH 2, 3, 4. Let us just make this OH disappear, avoid any confusion. So 5 and 6. And the name of this compound now becomes, so at 6 we have bromo, so 6-bromo. Then at 3 we have chloro, 6-bromo, 3-chloro, cyclo, hex, 1,4 dienol. All right. So this is the name of the compound. Then we have this next one, and here we start the numbering from the OH. So 1, then 2, 3, 4, and 5. And the name of this compound now becomes 2-bromo. Then we have 4-chloro, cyclo, pent, 3-enol. All right. The name of this compound is this. Moving on to the next one that we have over here. Now in this one, we see that we have CH2CHO at the top of this, and thus the main functional group is CHO, so 1 and 2. And this whole, the six-membered ring over here comes as a site substituent, all right? So the major chain here is CH2CHO, and therefore the name of this compound now becomes 2-cyclohexyl ethanol. All right. In the next one that we have over here, we start numbering from this. So 1, 2, 3, 4, 5, and 6. Notice now this OH has become a site substituent. All right. So now the name of this compound is 3-amino. Then we have 5-hydroxy. Then we have cyclohexane. Notice that we have not numbered this C in the ring, in the chain, and therefore we are writing it as carboxylic acid. All right. Now we are mentioning the whole carboxylic and the acid. In the rest of the COOH cases, we were writing oic acid because we were including the C double bond O carbon in these cases. So here in the next one now, when we start numbering this particular one, we have the CN as the major functional group, and 1, 2, 3, 4, 5, and 6. And now the name of the compound becomes 3-amino. Then we have 6-bromo. Also, we have cyclohexene carbonitrile. All right, so this is the name of this particular compound. in this one over here, the last example, so we start from here. So 1, 2, 3, 4, 5, and 6. All right. And the name of this compound thus becomes 2-bromo. Then we have 5-carbamoyl cyclohexane carbonyl halide. And here, since we have this Cl present, we call this halide as chloride. So we can just write carbonyl chloride. All right. So we have these as the IUPAC naming of the cyclic compounds. All right.